Hello, this is Orlando Castilleja. Welcome to a new tutorial on the use of SolidWorks flow simulation. In this time, we want to model a countercurrent to pipe heat exchanger. The objectives we want to achieve with this tutorial are as follows. Firstly, we want to set up a heat transfer model using flow simulation add-in in SolidWorks. Later, we want to show you how you can specify fluid subdomains when multiple fluids are required. Then we want to show you how to specify solid domains, and finally we want to set custom equations by using equation goals feature in SolidWorks. The main problem is described in this slide, and basically a countercurrent double pipe heat exchanger is used to cool down an ethanol stream that enters at 78 Celsius degrees. On the other side, water flows through the outer pipe and enters the system at a temperature of 10 Celsius degrees. What we want to determine here is what is the outlet temperature of both streams, and we also want to display what are the inlet and outlet velocities of both streams. Later, we want to generate a cold plot for the temperature, and we also want to generate a video or an animation with the flow trajectories plot showing the temperature map. Finally, we want to estimate what is the logarithmic mean temperature difference, and to do this we have to follow this equation. We will have to set up an equation, a custom equation, and we will have to enter this one. Okay. To obtain the 3D object, we're going to depart from a 2D sketch, and the main characteristics are shown in this slide. We will obtain something like this. The main object, 3D object, will be a solid of revolution. The main body will be this part, and at the end we will have to generate the inlet and outlet pipes. After getting our results, we will generate some profiles like this one. In this case, we are showing the temperature in a code plot and also the velocity profile. Finally, we will get an animation like this one. In this case, we are showing the flow trajectories, and what we are depicting here is the temperature, how the temperature changes within the tubes as a function of position. Remember that if you want to know more about the equations that are being solved here in these simulations, you can always refer to the technical reference document, and you can find this PDF following this route in your computer. Okay, we're going to move to the SolidWorks window. We're already here in the main window for SolidWorks, so we're going to select Part. Okay, I'm going to position on the front plane to start with a new sketch. And remember that we have to create something like this. We're going to depart from 2D sketch, and we're going to get a solid of revolution in order to obtain a 3D object. So we're going to create some lines firstly, and we're going to the sketch ribbon. I'm going to select a line, but I'm going to select a construction line. Okay. It doesn't matter where you begin. And I'm going to construct other lines. This line is for the inner diameter or inner wall for the first tube. This second line is for the outer wall, and I'm going to close this geometry, the other end. Okay. I'm going to use the smart dimension function in order to define what is the length. Before doing this, I'm going to change my unit system. I'm going to select IPS. And here I'm going to define that the length is 24 inch. Also for the other lines, smart dimension 24 inch. Okay, there you go. Here we can also define what is the diameter, in this case for the first pipe, for the inner pipe, and here I will define 0.69, and for the second line is 0.83. Okay, then here I'm going to draw a line from this point to the right, and this line is 2 inch in length. Okay, from this point I'm going to draw a line upwards and a line to the right. This line is going to be 20 inch length. And I'm going to create another line. These lines represent the inner and outer diameter for the annulus pipe. And here I'm going to define that the radius is 1.0335 inch, and the radius, for the outer wall, it will be 1.19. Okay. I'm going to draw another line to close this geometry, and I'm going to begin from this point downwards up to this point. I'm going to draw a line here, and I'm going to define that its length is 0.20 inch. Okay, I'm going to close this geometry. There you go. And on the other side, I'm also going to draw a line . Okay, remember this line is 0.20 inch, and I'm going to close the geometry. Okay, there you go. I'm going to the features menu and I'm going to select revolve boss base. Okay, the axis of revolution is already selected, is line 1, the construction line in this case, and I'm going to select this face for the first or the inner pipe, and then I have to select this. Okay, I also have to select these squares, both of them, and also on the other side I'm going to select this one and this one, and this will be to create the walls for the annulus. Okay, I'm going to click OK. There you go. Here we have created the inner pipe and the annulus pipe, but now we have to create the inlets for the annulus pipe. To do this, I'm going to position on the top plane here, and I'm going to the features menu, and I'm going to locate the reference geometry, and I'm going to create a new plane. Okay, in this case, this plane is, we have a distance of 4.19 inch from the reference plane, that is the top plane. Okay, I will click OK. There you go. I'm going to select again the top plane, and I'm going to create a sketch from it. I'm going to position in this space, and I'm going to draw a new construction line from this reference point. Okay, I'm going to select Smart Dimension, and I will define a length of 1.89 inch. And from this point, I'm going to draw two circles. This circle and another one. Okay, and I'm going to define that the diameter of the first circle is the outer circle. We have 2.38 inch, and for the inner circle the diameter is 2.067 inch. Okay, as you notice, it was created on the top plane, and I will select, well, I will start a new sketch from the plane we just created, and I'm going to select, okay, edit sketch, convert entities. Okay, I need to exit this sketch, select plane 1, sketch, and I will select this circle, and in the sketch menu I will select convert entities. Okay, also for the other circle, convert entities, and now we have a new sketch on the plane one. I'm going to extrude a new pipe from this sketch, and in the features menu I will select extruded boss base. Here in the direction 1 section I will select up to surface, and the surface is this one. Okay, and click OK. If I activate the section view, I will notice that here I have to create a cut, an extrude cut. So to do this, I'm going to position again on the plane 1. I'm going to create a sketch from the plane 1, and I gotta select the inner circle, click convert entities, and now you have a new circle on the plane 1. So I'm going back to the features menu, and I will select extruded cut. From the direction 1 list, I'm going to select up to surface, and I just have to locate this surface. Okay, there you go. Click OK, and now we have created this inlet. Now we have to repeat the operation for the other side to create the outlet pipe. So I'm going to deactivate the section view, and I'm going to position again on the top plane, and I'm going to edit the sketch. Create here reference, well, the construction line. Here we have a length of 1.89 inch. We have to draw 2 circles, and the diameter for the other circle is 2.38 inch. For the inner circle, the diameter is 2.067. Okay. Now we have to create another plane. I'm going to position here top plane, and I'm going to the features menu, and in the reference point geometry, okay, I'm going to exit this sketch. I'm going to position on the top plane, and from the reference geometry I will select plane. I'm going to click flip offset, so the new plane will be created on the other side. And I'm going to start a new sketch from here, and we have to copy these entities. Okay, we have to convert these entities. I'm going to select the outer circle and convert entities. Now the inner circle and convert entities. Okay, I'm going to the features menu, and I will select extruded boss base to create the pipe. In this case, in the direction 1 list, I will select up to surface, and I will select this surface. Okay, I will activate the section view, and we will have to do the same then on the other side. We have to use the operation extruded cut. So I'm going to the plane 2 again, and I will start a new sketch. In this case, I will select the inner circle and I will click Convert Entities. I'm going back to the Features menu and Extruded Cut. In this case, from the Direction 1 list, I have to select Up to Surface, and the surface is this one, and click OK. And that's ready. We already have the inlet and the outlet for the annulus pipe. I'm going to deactivate the section view, and now you can see that we already have the geometry we needed for our heat exchanger. In this case, the inner pipe will transport the ethanol, and the annulus pipe will transport the water. Okay, I'm going to save this work. And now we have to proceed with the flow simulation definition. And to do this, we're going here to the flow simulation ribbon. If you have not activated this add-in, what you can do is to go here to the options menu, select add-ins, and you will have to look for the flow simulation add-in. In this case, you have to activate the add-in with this checkbox, and you also have to activate this checkbox in order for the add-in to start up every time you open SolidWorks. Okay. Before starting with the wizard, we have to create the leads in order for the software to determine what's the best computational domain for the simulation. So in this case, I have to define a lead here, a lead here, in this side, and this side. Okay. Click OK. So now we can start with the wizard. You will go to the flow simulation ribbon and select wizard. If you want a custom name, in this case, I can use heat exchanger. The unit system I want to use is SI, International System. And in the temperature, I will define that I want to use Celsius as the unit for temperature. I'm going to click next, and in this case the type of analysis will be internal, but here I want to define that I want to study also heat conduction in solids. Okay, I'm going to click next. The fluids, the working fluids in this case will be ethanol and water. So I'm going to add ethanol and water, and I'm going to leave these configurations and click next. From the default solid window, I will go to the metals and I will select copper. This is for the solids, or the walls in this case. Here I don't have to change the configurations, and I will click next. For the initial conditions, I will leave that the pressure is 1 atmosphere, but in the temperature I will change it to 30 Celsius degrees. In the case of concentrations, I will set 0 for water and 1 for ethanol, and click finish. Now you can see that the computational domain has already been defined. I'm going to save the work. Okay, has already been defined. Remember that if you want to hide it, you go to computational domain, right click on it and click hide. If you want to show it again, right click and show. Okay, what we have to do now is to define the fluid subdomains. In this case, I will right click on fluid subdomains and insert fluid subdomain. Okay, I'm going to cancel this operation and I will activate the section view in order for us to be easier to select the boundaries or the domains. So I'm going back here to fluid subdomains, right click on it. So firstly, I want to define what is the subdomain for the ethanol. I'm going to deactivate the checkbox for water, and in the selection part I will select the inner pipe. Okay, here the initial temperature will be 78 Celsius degrees. The fluid will be ethanol for this domain, and the domain will be the inner pipe. And click OK. Now we have to define the subdomain for the water. That will be this one. When you select this domain, automatically the software recognizes that will be the annulus section. So the fluid will only be the water, and the initial temperature will be 10 Celsius degrees. Click OK. In the node for solid materials, I'm going to right click on it and will insert the solid material. I have to select the walls, and here from solid I will select metals and copper and click OK. We have already defined that the material for the walls will be copper, and now we have to set the boundary conditions. Right click on it. Firstly, I will select this lead 1. Remember, you have to select, right click on the boundary you want to select and click select other, and you will have to select this one. Okay, there you have. In this case, the type of boundary condition will be flow openings. The first one is already selected, the one we want, and here I will define that the mass flow rate will be 0.0001 kilograms per second. The thermodynamic parameters recognizes that the initial conditions were 78 Celsius degrees, and that the fluid that is coming into the pipe is ethanol. Okay, click OK. Now we have to define the inlet boundary conditions for the annulus pipe. Right click on it. Okay. I'm going to right click here and I will select, I think this is not the one I want. Okay, I'm going to deactivate the section view and I'm going back to create the boundary condition. Okay, the boundary is already selected. The type, remember that is flow openings, inlet mass flow. And here we also have mass flow rate of 0.001 kilograms per second. The temperature for the inlet of water will be 10 Celsius degrees. Click OK. Okay, now we also have to define the outlets. In this case will be lead 2. The type we have to select is pressure openings and environment pressure. This is okay, it's open to atmospheric conditions, and click OK. And the last one is also an outlet boundary condition. In this case will be this phase, this lead. Okay, there you go. Okay, now one part of the problem or exercise implies to determine what is the logarithmic mean temperature difference. So we have to obtain in this case, or we have to set some goals or some equations as goals in order to determine this quantity. So we want to know what is the outlet temperature for every stream, and we also need the temperatures for the inlet. In this case we already know what is the temperature in the inlet for both streams, but we need to set some goals in order to determine what is the outlet temperature for both for the water and the ethanol. So in this case we're going here to goals, right click on it, and we'll select, we want to insert surface goals. Here I want to select the outlets for the water stream, that is lead 2, and I want to recover from this phase its average temperature. Okay, I'm going to click OK. Here I can change the name, for example, temperature water outlet, and then I want to add a surface goal. I'm going to clear these selections and I'm going to select this outlet. Okay, and I'm going to select temperature average. Okay, and I'm going to write here temperature ethanol outlet. Now we have to set up this equation like a goal, or as a goal. So we're going to define this equation, delta T1 and delta T2, and finally we'll define the logarithmic mean temperature difference. So to do this, I'm going here again to goals and insert equation goal. For the first equation, that will be set, the name will be set as dt1. Here I'm going to add goal here. Well, I will select a simulation parameter, that will be the inlet temperature for the ethanol. Okay, minus the outlet temperature for water, and click OK. Another one will be DT2, and in this case will be the outlet temperature for ethanol. Minus the inlet temperature for water. Okay. So the last equation we need will be PT LMTD, and in this case we will have to select from a goal, and will be DT1 minus DT2, and I'm going to divide here by natural logarithm DT1 divided by DT2. Okay, invalid expression. Okay, maybe we have to. Okay, it's okay. Okay, ready. So now we have to define the mesh. I'm going to show the mesh, and I set it to 6. Okay. So now we can run the simulation. You have to go here to the flow simulation menu and click run. Okay, run. Now we just have to wait for the software to complete the calculation, and then we'll be back. The calculation is already finished. I'm going to close this window, and I'm going here to results and report. Well, I will have to go here to goal plots and insert. Here I want to show what is the value for the logarithmic mean temperature difference, and I'm going to click show. In this case we have obtained an average value of 42.06, and this can be taken as a logarithmic mean temperature difference. Okay, maybe you can also know from here these other variables, and now we know that the outlet temperature for water is 25.58, and the outlet temperature for ethanol stream is 43.16. Okay, I'm going to click OK. Okay, remember that our problem, we want to know what is the outlet temperature of both streams that we just saw, but we can show it in a table here in our sketch. So I'm going here to the surface parameters. I'm going to right click on it and I'm going to select the outlets, all this outlet, and I want to know what is the temperature of the fluid and its velocity, and show. Okay, here we have these values: 25.27 Celsius degrees for the outlet in the water stream, and I'm going to add a new one for the ethanol outlet. Okay, here. Okay, there you go. Remember, we need the temperature of the fluid and its velocity, and show. Here we have this value. The temperature for the outlet in the ethanol stream is 55.26 Celsius degrees. Okay, now we have complete the part A. Okay, we need to display also the inlet velocities of the streams. I'm going back here, surface parameters, insert. I'm going to select this face. Okay, and I want to know what is the velocity here. Now for the water stream, velocity. Okay. Letter B is already complete. Now we have to create a cut plot for the temperature. To do this, we're going here to results. I'm going to select, right click on cut plots and insert. It will be created following the front plane, and I'm going to select that we need 25 contours, and I'm going to click OK. In this case, it is supposed to be displaying the pressure, but I'm going to select display menu and transparency in order to see what is happening inside. And in this case, I want to show the temperature of the fluid. There you go. If you want to change the lining, okay, there you have. Maybe we could select more contours. Okay. Now we want to display a flow trajectories plot for the temperature, also for the temperature. We can hide this cut plot, and I'm going to position here in flow trajectories, I'm going to insert a new one, and I'm going to select this starting point and this face as a starting point. Here the number of elements I want to show will be 100, and I want to display the temperature of the fluid. I'm going to get a preview, and maybe here I can increase the size of the arrows. Okay, there you go. This is a flow trajectories figure, and we can animate it. Here you can observe how the temperature of the fluids is changing along the axis of the heat exchanger. Maybe this section that you can see what is happening here, you can improve this animation by increasing the mesh elements, the number of mesh elements. Okay, now finally we have to estimate the logarithmic mean temperature difference, and we have already done that. Here we have determined that this logarithmic difference is 42.06 Celsius degrees. Okay. Okay, this is the finish of this tutorial. I expect that it's useful for you and that you can apply the knowledge you just acquired in all your projects and in your class of fluid dynamics. And if you have any other question or message, you can send me an email and I will be glad to help you with all of your questions. I expect that you stay healthy and safe, and see you on the next tutorial. Goodbye.